Let's solve this example using different methods. So what is given? The mass of a flagpole is given and the angle theta is given. So here this is the theta which is given as 25 degree and the center of mass. So first thing we need to analyze the different forces acting on the system. So this weight, here you see this weight is the only force that acts in the system. So this is weight, or you can say this is force. So this force equal to mg. We know weight equal to mg. So 3.2 into 9.8 equal to 31.36 Newton. Newton is the unit of force. Now we have to calculate this angle theta between r vector and f vector. Now draw a line from the fixed point to the force. So this is your r vector and the force is given. So we need to calculate this angle theta. So how to do that? So it is basically like this. So this is your theta. So if you make one parallel here, so this will be angle theta is again 25 degree and this is 90 degree. So the total angle between my r vector and f vector is 25 plus 90 equal to this much. So I will plug this value here. My r is given 1.6 into 31.36 into sine of this much. So we will get 45.47 and the unit of torque is Newton into meter. So now for the second method, we break this force into its component form. So force equal to mg. Now draw a perpendicular here to this inclined. So this is, we know this is mg cos theta and this is mg sin theta. So now torque equal to, torque due to this mg sin theta term will be 0 because this fixed point and the force component are in the same line. So torque due to only cos theta will be there. So torque due to mg cos theta equal to r into mg cos theta. So everything is given. So r is 1.6 into mg, we get 31.36 into cos of theta. So theta is the angle this one. So cos 25 degree. So now if you calculate this, we'll get into cos 25 degrees. So we'll get 45.47 Newton into meter. So you see, you get the same result. So let's solve this same example with the method 3. In method 3, we'll basically draw a perpendicular line from the fixed point to the force. So this is the force or weight and this is your r vector. And the magnitude is r perpendicular. So you have to calculate this r perpendicular first. So r perpendicular in this triangle here. In this triangle, r perpendicular equal to r into cos theta. So this is 1.6 into cos 25 degree. So if you calculate, you will get 1.45. So this is basically 1.45 meter. Now torque equal to r cross f. So here r is r perpendicular into F into sine theta. Theta is 90 degree. Here you can see the angle between R perpendicular and force is 90 degree. So R perpendicular is 1.5 and force or weight is 31.36 equal to again 45.47 Newton into meter, which is same that we have already calculated before. So here you see there are different ways to calculate the torque. So these are the few tips to solve the triangle based problems, like if the sides of a triangle are given, this is 90 degree and theta is given. If you take cos theta, then it will be B by A. If you take sine theta, it will be C by A. If you take tan theta, it will be C by B. So in the previous problem, A and theta are given and you have to calculate the B. So we use this formula here. So B equal to A into cos theta. That's what we have used in the previous question.